Okay, guys. So hope everybody had a nice long break. We are going to spend this first day is just reviewing, just to get our tools back in the forefront and make sure that we're ready to move on with the unit. So if you'll recall, we were solving systems before we left for the break, and we're basically right still in the unit. So I believe this unit 5. So systems review. Whoops. All right. So solving systems review. And we've talked about 3 different ways to solve these. So recall, a system is when you have 2 or more equations, linear equations, right? What is a system? Is a system. That's going to be 2 or more, right? 2 or more linear equations combined. And what we're looking for are solutions, right? So, and there are 3 types of solutions. Okay. The most common, the most sought after, right, is an intersection. Okay, and that's just going to be an ordered pair, X, Y. The next type would be a parallel. And that is going to be no solution. Okay, and then lastly, you would have the same line situation where the equations would simplify or graph on top of each other. And same line is our infinite solutions. Okay. So nice little infinity symbol right there. Okay. So we'll talk about the 3 types. Obviously, the first one would be graphing, and this just helps to illustrate what kind of system we have and solution that we're looking for. In which case, right, we want our y-intercepts to be as small as possible. Okay, so example 1, graphing. Okay, so we have y equals x plus 8, and we have x plus y equals 2. All right, so if we're going to be graphing, we want to graph, obviously. So we're going to draw us a nice little graph here. We're going to need 8, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 6, 7. All right, so there's our graph. We can go ahead and graph this top one because we already know it's in slope-intercept form, right? That's the ideal format for graphing. You have a y equals mx plus b setup, and so you can identify the y-intercept and the slope very easily. So we're going to call this our, let's say teal, maybe, teal line. So we have a y-intercept of 8. So 1, 2, 3, 4, 5, 6, 7, 8. I believe I drew exactly 8. Now I want to go up 1 over 1. That's what the slope is here. But right, that takes me off the graph. So I'm going to flip all that, and I'm going to go almost -1, -1. So it's down 1, left 1, right? Down 1, left 1 for my dots here. So I can get my line going. Seems as though my pen's got a little mind of its own. That's okay. All right, so there's that line. Looks something like this. And again, since I'm drawing this graph, it's not going to be completely accurate. And now we can take this one and we can call this one our red line. But there's a problem, right? We're not in slope-intercept form. This one's very easy to move around, right? We're just going to bounce that x to the other side of the equal sign, which in turn is going to change the sign of the x. Okay, so it's a negative x plus 2. So I can graph that one, right? I've got a plus 2 y-intercept here. Is a down 1 over 1 scenario here. So this line, but I want to work towards the other line. So I'm going to go up 1, left 1, up 1, left 1, up 1, left 1. And I believe, right, we should be hitting right here. So that would be our intersection for our line. Again, not entirely accurate, but I'm going to guess that point, right, my first guess, because I drew it, I've got to kind of guess at that point. I'm going to say that point is -3, and then 1, 2, 3, 4, 5. -3, 5. And does that exist as a point? So this would be -1, 3, -2, 4, -3, 5. So yes, that follows the pattern at least. So let's try it out, right? So is -3 plus 8 5? Yes. And is -3 plus 5 2? Yes. Okay. So that would be our solution, right? That is our graphing solution. And we can always graph as long as the y-intercepts will allow us to graph. But in the case of, right, where our y-intercepts would not make it feasible, we would use one of the alternate methods. So we've got substitution. Okay, and so we can look at substitution as another method of solving. And substitution is always ideal if one of ours is already set up to be substituted and the other one is not. And maybe the y-intercepts would cause a very large graph where it's not really feasible. So example 2 will be under substitution. Okay, so we've got 3x minus 7y equals 41. And we've got x equals -2y minus 21. Okay, so these are definitely not set up for graphing. They're definitely not in slope-intercept form. I'm going to end up with fractional y-intercepts, which, you know, is very tough when you graph, because then you have to adjust the scale to match the fractions and to get solid points, and it just becomes a mess. Okay, but that's not to say that we don't have solutions here. The great thing about this one is it is set up already for substitution. Okay, that x has already been isolated for us. So all I need to do is take this, what x is equal to, and substitute it in, right, for this x. So I'm going to take this value and I'm going to take it up into the top equation. Okay, so it looks something like this, right? 3 times -2y minus 21 minus 7y equals 41. Okay, so again, all I did was take what was given, x is equal to, and put it in place of x. And so now I can go ahead and do my distribution. So -6y minus 63 minus 7y equals 41. Okay, go ahead and combine your like terms. So I've got -13y minus 63 equals 41. And then going to add my 63 over. So -13y equals, and that's going to be a positive 104. Seems good. And then lastly, I would divide by -13, which I know 10 times 13 is 130. And so back that down a little bit. I'm going to go with a -8. Okay. And now I know the first part of my ordered pair. That's a -8. I just need to find my X value, which is very simple. I just go back to one of my originals and substitute. Doesn't matter which one. Since this one's already isolated for the X value, I'm going to substitute it right there for that Y. And then whatever I get when I evaluate is what it is. So no extra needed. So -2 times -8 minus 21. And I've got X equals positive 16 minus 21. Almost got myself there. And I've got -5. Okay. So -5, -8. And that is substitution. Okay. So we want to, use that when necessary. And some people grasp that one very well, and they'd rather use that one exclusively. And there's nothing wrong with that. It's not my preferred method, but definitely a method you could use no matter what. Okay. And so then we can move on and we can look at our last method here, and that's going to be elimination. And this one's my favorite because, right, it's fancy. For me, it's fun, right? We get to manipulate things, and it seems like we're breaking laws of mathematics as we manipulate them, because we are deciding to do things that aren't given. But for me, that's the fun of it. Okay. So in example 3, in elimination, I'm going to give you this one, and this was where we left off. Okay. So 2y minus 7 and 2x minus 5y equals 10. Okay. And so the first thing, right, you have to little star for ourselves. They must be lined up, right? So that is a must when you're doing elimination. They have to be lined up. Everything needs to be. Now, it can be lined up however they want, right? You can move this 5y to the right here, and it'd be 2x equals 5y plus 10. They would line up with each other, and that's fine. I typically just tell my students, go ahead and convert everything to standard form, because it will allow you to utilize some other features, which we'll go over towards the end of the unit on the calculator, if they're both in standard form. Okay. So I need to move this one around. Essentially, I'm going to move this 2y over, right? So I've got a new setup here. I've got 3x minus 2y equals -7. Okay, and then 2x minus 5y equals 10. And now you can choose whichever one you'd like to make a match. I'm going to go with the 2 and the 3. So multiplying those two, we got to get common coefficients. So the first common coefficient between these two would be 6. So I'm going to change that to 6 and that to a 6 by multiplication, and whatever happens with the rest of it's what happens. So again, let's manipulate it. That's 6x minus 4y equals -14. And then I've got 6x minus 15y equals 30. Okay, so again, that was just multiplying that 3 all the way through and that 2 all the way through. I'm going to go ahead and subtract these two so that we can get us 0x, right? That cancels those out. That's the whole point. So -4 minus -15, that's 11y equals, and that's -44. Okay, so y equals -4. Now you could reverse the whole process to solve for y. You could manipulate to get a 10 and 10, and then solve for the x by eliminating the y. But once we have one, all we need to do is plug it back in, because we already know our solution set, right, is going to be something -4 And so I'm going to go ahead and use that top one. So 3x equals 2 times negative 4 minus 7. So that is 3x equals negative 8 minus 7. So 3x equals negative 15, which means x equals negative 5. And I'm done. Okay, there's my solution. I could check it, as any math teacher should tell you. You need to check your answers, right? But if you're confident in your work, that's not going to be what I tell you you have to do. That's not a have to do. Now, if you're getting a lot of these wrong, and you just can't figure out where you're going wrong, you might start checking your solutions before you enter them as answers, right? Because they either work in both equations or they don't. So since I solved for this one, try it in the other one, right? It's 2 times negative 5, that's negative 10, plus 20. So negative 10 plus 20 is 10. It works in both. So I know we're good to go. All right, so that's your little mini review on systems so far. Hopefully, everything was recent for you enough that you remembered it and you're ready to go forward as we look into solving more and more types of systems. Okay. So any questions, comments, concerns, just give me a message and we'll get back with you as soon as we can. Thanks, guys.